Thank you, everyone, for being here and letting me be a part of your day. Yeah, this is in so many ways a huge honor because I have nothing but the highest respect for the JPoint team and the Jug RU team there who do such amazing things. The great community there. I just love to be a part of it. Every time I get a chance, I try to, unless something just doesn't allow it. So I'm just happy to be back. Whole new format, obviously, for obvious reasons. And interestingly enough, everything is new because this talk, when I came up with the idea for this talk, it was based on a very popular talk that I had given last year, but it was more of an introductory talk in terms of dealing with messaging platforms, which was great. I mean, I covered some ground that maybe people had thought of before, but I wanted to take it in a little bit deeper direction and maybe explore some things that were kind of on the periphery, on the edges. I still obviously in this talk cover the foundations because you obviously have to build on something, right? But I wanted to kind of explore some areas that are a little less explored, and things that if you're not using messaging platforms, maybe would give you some ideas on how to use them. Most of us are in some capacity in our organizations. We already have messaging platforms in place, so that's kind of the deeper dive part, right? Because if you're already using them, there are probably ways you could use them better, and that's the how to tame and get the most from your messaging platforms. If you are new to them, that's perfectly fine. Again, I don't think you're going to be lost at all. So please don't go away and come back. But anyway, my name is Mark Heckler, as the Dimitri said, and I do work for. It was Pivotal, right? Pivotal and VMware were sister companies, and VMware and Pivotal had worked together on so many things. That it kind of made sense when the merger happened, and VMware, I guess acquisition is a more accurate word, because Pivotal became a part of VMware, and the Spring team and all the same folks largely doing all of the same things largely to get in the same groups, the same objectives are still happening. So I'm still doing the same things with the same teammates and same colleagues. In fact, another of my teammates is going to be on here later on. I think not long after me, Josh Long. So I'll hand it off to him and his ever capable hands to maybe explore some more of the reactive bits as he comes on. Now, I am going to be talking about some imperative code. I'm going to be coding imperative code as well as some reactive code. But again, this is a very natural progression, I find, the way I try to present it. So if you have any questions, we will be breaking at certain points to kind of address those, as well as afterward. We have the chat channel. And then, of course, if you think of something 10 minutes after the chat channel closes, by all means, please do email me or hit me up on Twitter, as the indications are here. These are two email addresses that I use, the ones that I check the least infrequently. I'm not huge on email, but I do check it from time to time. But I am on Twitter largely, well, pretty much all hours of day and night. I've tried to give it up. I can't. So if you want to reach out to me on Twitter, it's mkheck. If you want to direct message me, so you have a question, comment, or feedback that you don't want to share with the world, that's fine too. Just DM me. My DMs are open. So with that, I'm going to be covering kind of the concepts in the background rather quickly. I don't want to gloss over it because I think the foundation is important, but I don't want to belabor it either. So the key part of this talk is really doing more with less. I mean, no one's boss ever comes to them and says, hey, great work last year, but you did too much work and you didn't cost us enough money. So please do less and let me double your budget so you can do less. Nobody ever does that. And if they do that, if you are in that rare situation, please let me know. I'd like to study that further. But we're always asked to at least do more with what we have, and many times to do more with less. So we're always trying, as developers, we're always trying to figure out better ways to do more and to provide more value to our organizations with what we have. And that's the kind of the germ of the idea for this talk. Because again, most of us have messaging platforms that are in use throughout our company, but probably aren't used to their fullest capabilities. A bit about me: I have co-authored a couple of books and contributed content and code to several other books. I also have another book that I'm working on and trying to wrap up in the next 2 or 3 months. So I'll mention that here or give you a bit more information on that shortly in case you're interested. I am an architect and developer, and as you might surmise from the next bullet point, where most of my expertise has been it's been in the Java ecosystem. I am a Java champion, a Java 1 rockstar, a groundbreaker ambassador, received a few other honors and awards that, while wonderful and I truly appreciate them, still mean I have to buy my own coffee. Which actually, coming into 2020, was a good thing, because now I'm spending more time at home and buying my own coffee, so that's fine too. Good coffee, by the way, because who can drink bad coffee? So I am a professional problem solver. That's not my official title. It's just what I do. It's what you do. It's what we all do. That's kind of, I think, why we gravitate to this field, because we like to find things and fix them to make things better in some way than what we found. So yeah, that's kind of how we tick. I am a Spring developer and advocate. I love to code. I love to commit code, and I love to talk about code, and how, again, how it helps us to solve problems. So that's my official role, right? I also am the sole creator and curator of Spring Noticias en Español. So if you're a Spanish speaker, by all means, you have resources to share with the greater Spanish community, by all means, reach out to me. If not, that's fine too. It's just something that an area that I felt I could help out in, so I do. Regarding that book, I signed on with O'Reilly end of last year, and I'm working feverishly on the Spring Boot Up and Running book. And there is early access available. If you follow the link there, the shortened link, bit.ly Spring Boot book, you can gain access to the first, I think it's 4 or 5 chapters of it, and kind of see how I'm winding up with that. Wind up for the pitch, if any baseball fans are out there. Um, in 2020, I'm not even sure I remember what baseball is. But anyway, I think it's going to be a good book. We'll find out, right? If nothing else, it'll serve as good notes for me to refer back to, and I need to reference how, best practice on doing something that I've forgotten or something. But yeah, O'Reilly, working on that, and I think it's coming together nicely. So check it out. Today, though, we're going to be talking, and of course, we're going to be using Spring Boot, but we're going to be talking about why use message platforms, where do they fit in a distributed architecture. If you have a massive monolith, or even a microlith, if you will, chances are it's even then you're not talking about an isolated thing, right? Because no application is an island. No matter how large it may be, it probably has to interact with other services or other applications. And certainly when you start decomposing that into more nimble and agile microservices, you're going to be seeing more and more interactions between the different services, the different capabilities that you're trying to provide as a whole to your clientele, your end users. Messaging platforms, I mentioned reactive earlier, and reactive is used in many cases to increase scalability, to encourage and increase the capabilities in terms of communicating among services, but it's not the whole story, right? It's an excellent, excellent solution. That's why we use it. But there's nothing like messaging platforms to give you the versatility, the flexibility in terms of routing messages and how to handle messages. And it all breaks down to messages, right? Because if whether you're talking about a monolith, microlith, or microservices, or nanoservices, or whatever the new thing is that becomes in 2021 or two. But you're going to be interacting. There's going to be an interaction, or should say a series of interactions that occur among all these different islands, these services. And when it comes down to that, it is a message in one form or another. Nothing gives you the ultimate flexibility at this point in time and for the foreseeable future that a messaging platform will give you. As well as you have durability and things like that. So you have guarantees. And sometimes folks will ask, well, what happens if my messaging platform goes down? Isn't that a weak link? Your messaging platform is typically provided as part of your critical infrastructure. So whether that's internal or a cloud hosting provider, but it's part of your critical infrastructure. So if it goes down, chances are everything is down. Your whole application architecture, your distributed system is down entirely. So it's typically as robust as it gets, right? If it's gone, everything is gone. So that provides a certain level of a certain set of guarantees, if you will. It also allows you to have that durability. If a producing service produces a message and sends it, your consuming services may not even be online. And depending on your durability settings and what your how you have your system configured, that's not an issue at all. That message just sits and waits. And when a consumer comes online, it checks and says, "Oh, I have a message," and it consumes that message. If something breaks in the middle, that those messages are stored and retained until such time as something can come online and address them. So it gives you a lot of security, reliability, resilience, as well as the ultimate flexibility in terms of how to deliver messages, multiple messages, instances of each message, routing in different ways, and what have you. Some examples of different leading messaging platforms. Well, of course, you have RabbitMQ. RabbitMQ has been around for a number of years and is super robust, crazy flexible, probably the ultimate in flexibility in terms of routing, as well as very, very scalable. You have Apache Kafka, which has kind of made a name for itself in terms of its performance and scalability, not to take anything away from its routing compared to Rabbit or Rabbit's speed or scalability, because they both, there's a lot of overlap there, even though they do address things in a very different way. But certainly those are excellent options that are provided. They're both open source. They're both available on a number of cloud hosting platforms. So that gives you a lot of capabilities that you can deploy in-house, you can deploy externally, or have deployed externally, and everything works the same, right? You also have things like Kinesis, Amazon Kinesis, and Google's Cloud Pub Sub, and Azure Event Hubs, and many other options, even from those same cloud providers, as well as other cloud providers that give you options as well. So Solace, PubSub Plus, you have a ton of different options that in many ways are great if you could standardize on one. The problem is, of course, that, again, we deal with a lot of different problem domains. We have customers and clients and partners that may have standardized on a different option, which then adds complexity back into the mix. And that's where really Spring Cloud Stream's value comes in. Many other capabilities it gives you, but I think that first step, you look at it as a way to sensibly abstract from some of the specifics of each of the different cloud platforms, so that you can manage things at a much more higher, a holistic level. It gives you full access to all of the tweaks and settings underneath. So if you spend 80% of your time dealing with Kafka, you're not limiting yourself. But it gives you the capability to address that at a higher level abstraction. So you can deal with Kafka in many ways the same as you deal with Rabbit or Kinesis or Event Hubs or something like that. And then, of course, when you need to dive in and deal with specifics, you still can. So Spring Cloud Stream is a very capable abstraction that kind of gives you superpowers in terms of how you develop things, because you can focus on the things that by and large consume most of our time and address most of the business value and provide most of that business value, which is getting a message from one point or multiple points to other point or points, and handling that properly. And I think I've kind of already covered why use it. It gives you that level of abstraction that's wonderful in terms of freeing you up to focus on the things that you primarily need to focus on, while still being able to get to the things that occasionally you might. It also gives you some platform independence. So I mentioned the integration. It makes integrating different messaging platforms trivial. It also makes switching between different platforms trivial, which is kind of an exceedingly rare use case, or you hope it is. You hope that your boss doesn't come in one day and say, "Yes, I know we standardized on Rabbit, but we need to move everything to Kafka by tomorrow," or "We're on Kafka, and by this time next month, we want to be on everything 100% migrated to Microsoft's Event Hubs." That's if you're in that situation, I'm sorry. Hopefully, there's a good reason for it. But regardless, the ability to do that and to make it simple, dead simple for you as a developer, is hugely powerful, especially if you think you might need it. It also gives you, Spring Cloud Stream gives you the capabilities of deploying things differently dynamically. And I'll show that as well as we go through the demonstration, because I think that's incredibly important. So you don't have to tie to one, and then even if it's trivial to make the changes, you're still in there tweaking code and things like that. By and large, you can change it from your environment, which is, again, even more immensely powerful. So really nice. So at this point, I'll ask, are there any questions before I go any further with this? Do we have
So
anything
I would
outstanding,
say,
Dimitri?
no, I'll be quite honest. So we are impatiently waiting for the code.
All
See, we
right.
want to see it. Yes.
You are my people. I
Although,
love this.
absolutely, we wait for the code.
Yes, well, and not to take well, a 20-minute or 20-second, sorry, a 20-second diversion. I think the conceptual background is critically important, so you kind of see where we're going with this, right? But I do think if you're like me, I think that it makes a lot more sense. You internalize it a lot better when you see it in action, because that's when you engage brain and fingers and see it all. It's like, okay, now that makes sense. So with that, I'll go ahead and launch forward. And then I'll stop again right before we do launch into the code in case anyone has any context questions at that point, and then we'll code. So
I would
what I
just
want
say
to
from
do is
my side
start.
that
Oh, yes.
don't hesitate. Yeah, don't hesitate to ask questions. So this is something I would like to say to the audience. Don't stop yourself from asking questions. This is the moment.
Yes. By all means, if you have questions, ask them. If I'm going to be addressing them in the code, I'll just tell you that. That's not a problem at all. And if you think of something, and I mentioned this earlier, I think if I didn't, apologies, but if you think of something 10 minutes afterward, that happens to me all the time. That's when the best questions come to you. It's right after you walk off and go into the next session or whatever. But please, please, please do reach out. My goal is to answer all questions, even if we pick them up later and answer them. That's perfectly fine, because I find this stuff fascinating. I think it's an incredibly powerful toolbox, and I want to share it all. So yeah, questions now, questions later, all good. I'm going to start off with Spring Cloud Stream and a messaging platform. I usually start with Rabbit. Rabbit, again, is something that has a lot of capabilities, a lot of power, and I think it's an excellent starting point. I do have just a little bit of background because I forget to mention this sometimes. I do have 3 containers running in the background, so I can do everything locally, which is how we do most of our development, right? We do it right on our developer workstations locally. And then when we deploy to prod, we push it out and we change environment and point to a hosted instance or what have you. But I'm running everything in 3 different containers. I've got a RabbitMQ container running. I have Kafka and Zookeeper running. So I've got everything running in the background, and that's why I'm hitting it all locally. Just so if anyone has that question, that's what's happening. So that's why I don't have to provide like host and virtual host name unless I push to a cloud or deploy to a cloud, and then I can point to that. But everything in Spring is optimized for the developer experience. Which makes sense, right? Because on our developer workstations, generally it's consistent. We're dealing with local host and a port for various different services. It's when we push to prod that everything changes, because your production environment may be hosted by Microsoft. Mine may be hosted by Google, and somebody else's may be hosted by Amazon. And even within Microsoft, for instance, you have vastly different configurations and settings that you want to use. But on our local workstations, it's much more consistent. So we typically, as with all things Spring, we take sensible defaults, right? We have opinions, and by and large, with those opinions, it takes a lot of the stuff, the boilerplate and setup that you have to do in so many other languages and frameworks, and just does away with them. Doesn't mean that you don't have the option to change them typically, and I'll show you that as well as we go. A property setting, or if you create your own bean, it'll override the auto configuration that Spring Boot provides. Super simple to do, but in 80 to 90% of all use cases, you just don't have to do it. So it lets you focus on the stuff you want and need to focus on to provide value to your organization. So yeah, anyway, that's actually about a minute bunny trail. So we'll go back here. This is the first kind of setup that I'm going to be coding, which is 3 different services. One is a source; it produces values, and I'm going to be pulling those from somewhere else, even an external source, and then wrapping them or filtering them in some way, processing them as a kind of an API gateway. I can't wait to tell you about that, but I'll have to for now. So I'm taking these source values, and my source service is pushing them into a Rabbit pipeline, and I try to use that term pipeline, so I don't devolve into exchanges and queues or topics or anything specific to a particular underlying provider. But if you're using Kafka, think topics. If you're using Rabbit, think exchanges and queues. But it all at a higher level conceptual on the conceptual plane, it's all the same, right? We're pushing messages into a pipeline so that something else can pull them out of the pipeline and do something with them. And that's that starting abstraction point. So the source produces messages, sends them on. The processor, one or more processors, will take those messages and process them, will transform them in some way, and then push them on. And then at some point, they hit the end of the line. And by the way, as I show in the next slide, you can scale this out in many different ways. You can actually have processors that send to other processors, which send to other processors, and then syncs. This is just kind of the simplest example that covers all of those three different permutations. And of course, you can create your own interfaces and define things differently if you want to. But by and large, the predefined source, processor, and sync abstractions work for almost every use case. So a source produces values. You'll have processor or processors which will transform those values, and then the syncs will consume them. That's the end of the line. For that particular message, the sync is the end. So it completes processing, and that message has lived through its entire life cycle. Scalability is very simple. I'm not sure we'll have time for that, but it's a very simple idea and concept, and I can mention it. And of course, you can see it in the code later if you go look in the repos as well. You have a lot of flexibility. Here we had Rabbit. And now if we need to switch to Kafka, it's a trivial exercise. Don't tell your boss that. I'm kidding. Tell your boss that. That's fine. But you may not necessarily want to encourage that practice. But you can. You have that flexibility to, if it's merited, to change the underlying messaging infrastructure for one or more pieces of your entire architecture, and to do so that's in a very non-traumatic way for your organization, for you. You have versatility in that you can integrate these things extremely easily, which again gives you a lot of power and a lot of flexibility as a developer. So I mentioned consistently source, processor, and sync because these were the names that were given to the interfaces that were defined in Spring Cloud Stream. These are considered the legacy API, because about a couple of years ago, maybe now, we started looking at ways to make this more less of a leaky abstraction, I should say, because Spring Cloud Stream was based on Spring Integration, which is a very powerful component library. But what it did is it leaked a little bit of the abstraction out, so you kind of had to understand and know Spring Integration to fully appreciate Spring Cloud Stream. But when you look at ways to simplify, when you look at ways to have more of Spring Boot's approach, which is more of an auto configuration approach, where it understands what you're trying to do simply by examining your code, it became very obvious very quickly that these three concepts, a source, processor, and sync, actually mirror something that is implemented in Java itself, which is that of a supplier, a function, and a consumer. A source produces values. Well, that's what a supplier does in Java. We're not even talking Spring or Spring integration. It's a Java supplier produces values of some type. A function will transform those values from one thing to another thing, and a consumer will consume those values of a particular type. So it made a lot of sense just to go with that very basic idea and to wrap that in and roll that into Spring Cloud Stream. This is the evolved API. I'm not really going to touch much on the legacy API, even though it's certainly out there. It'll be supported for a long time. But this is the future, folks. This is kind of it's a great way to live. So that's where we're focusing today. And we're going to cover a few, I think, very useful bits and bobs. If time permits, again, if not, please start the repo. Please ping me afterward. Happy to talk about more and more of these things as we go. So with that, let's code. Unless there are any questions, I can address those right away.
There are
Fire
actually
away.
some questions. Yes, one of them is a bit general, but the idea is that what we are doing right now, the streams, as you say, we somehow got to the concepts of the Java itself. Is this a step to functional programming when you do this?
Yes, yes. As a matter of fact, which, well, you'll see that here momentarily. So that's a great question, a great lead in. Thank you. Yeah, it's much more of a functional approach, and which I find, and you will find, I'm certain, leads more into a very nice. It's a nice segue into functional reactive programming as well. So I don't go too deep down that road, but I think you'll start seeing some very nice breadcrumbs that are dropped as we proceed.
Okay, another question from Dimitri also. Are there any special goodies in Tansu that makes life easier when we mix streaming systems in Spring?
What was the question again?
So are there any special goodies in Tansu that makes the life easier when we mix streaming systems in Spring?
Ah, okay. Now, for those of you who aren't aware, Tanzu is the kind of the overarching branding for the build, deploy, and maintain, and I can't remember the other term, but for building and deploying code and working code for production systems. And that's kind of the overarching brand that covers all of the entire life cycle of idea to production, right? So yes, there will be some interesting things. I won't have time to go into those today, really, but certainly when it's probably a truism to say at this point that either everyone is working with Kubernetes or is exploring Kubernetes for a potential target of working on Kubernetes at some point down the road. Different organizations are in different stages of that. But I think everybody has pretty much accepted, sort of as Linux has kind of taken over the server space by and large, that Kubernetes is kind of eating the cloud, which is good, right? Kubernetes provides that useful abstraction, that useful underlying platform architecture that we can all kind of count on, the dial tone of the internet in many ways, or not the internet, the cloud, I should say. But Tanzu is a way of bringing that very basic functionality of Kubernetes and making it much more consumable, much more powerful for applications. And of course, Spring will run best on Tanzu, will run best on Kubernetes. So yeah, stay tuned on that. Like I said, I don't get into that here today, but there actually have been a couple of good talks on our Tanzu Tuesdays. I didn't even think about mentioning this, but my team has a Tanzu Tuesdays that we broadcast on Twitch, and we've had a couple of really good recent episodes where we've talked about kind of the intersection of Spring and the various Tanzu underlying pieces and kind of how it's coming together and where things are headed. So check those out if you haven't already. It's out on Twitch.
Wonderful. So let's go and code.
All right. Okay. So for those of you who don't recognize this gentleman, this is Maurice Moss from the IT Crowd. That is a TV series, a Britcom from a few years back. If you haven't watched it, you're missing out. So please do. Okay. Pardon me. Okay. So let's get started here. Let's see. I need to pop up this start spring.io. Got a little delay there. Okay. So what I want to do, and I have a checklist here because again, well, not all, but 90+% of this code, well, pretty much 95% of this code is brand new. So what I want to do is show you some cool stuff, and I don't want to miss anything. So Dimitri, how much time do we have left? We have like roughly half an hour ish, maybe a little more.
Even more, 42 minutes.
Okay. So, oh, there it is. There's my timer. Okay, good.
Okay.
This should work. All right. So,
Don't stop
so I
yourself.
don't what? I'm sorry.
I said don't actually stop yourself. Enjoy.
Okay. All right. Well, good. Okay. So I have the list. I want to make sure I don't like skip over something because I have done that before. Very quick bunny trail. I gave this talk, not this talk. I gave a talk one time and I was trying to fit it into the time frame that I had. I was consistently running a couple of minutes over. I was stressing about it. And when I gave the talk, I came in a couple of minutes early. And I was so excited that somehow I had managed to come in under time. And I was so pleased, very happy. The talk went well. People seemed to respond very well. And I walked out into the hall and realized I'd left out one section that I wanted to cover. Obviously, not the end of the world, but that's how I got it under time. So I was so sad after that I left out a piece. So I have a checklist. I'm not going to do that today. But I'm going to start off, and as I mentioned, I want to create 3 different projects so that we can create our service, various services, our source, processor, and sink, or if you prefer, our supplier, our function, and our consumer. So this is the Spring initializer. This is how you typically start by start creating Spring Boot based microservices. You don't have to go here. You can curl this. You can use this from your IDE. You can even hand write Spring Boot applications. Not the most productive use of your time though, right? Because this gives you a giant leap forward. It allows you to choose dependencies. It doesn't generate code per se. It does, I guess, generate your main application class and main method. But what it does is it allows you to choose capabilities, and your dependencies are brought in as higher level starter POMs, if you will. And those POMs, when you want to provide a certain capability, they bring in the dependencies that are version synchronized and tested, so everything works together without having to try to do this dependency whack-a-mole and chase down why something doesn't work because one of the third level dependencies updated last night and now it broke everything else. So you don't have that with this. You can override should you want to, should you need to, but by and large, it just works. It makes your development experience so much easier. So we'll start here. I'm going to create a Maven project, but it gives you options, right? If you're a Maven developer, you can generate a Maven project with a Maven build file, your pom.xml. If you're a hipster, you can generate a Gradle project. That's fine. You just check here. But I'm going to keep it fairly straight down the line here today. And we'll go with Maven and we'll stay with Java. Again, Kotlin and Groovy support is excellent, but we'll stay with Java for today. I'm going to use 2.3.1, which is the production version of Spring Boot. But as you can see, we have milestones and snapshots ahead. We have prior versions out here to a point. So you've got your previous snapshots, your couple of previous versions. And then I'm going to change just a couple of my basic metadata points here to the Hecklers, because that's my domain. Why not, right? The artifact I'm going to create is my source. So let's see, that would be my source service. And let's see, so this is my demo source. And we'll just say demo. That way I don't have to change that later. The packaging we're going to use is our Uber jar or our executable jar. That allows you to bundle and bring your dependencies with you. Again, deployment options are abound even with Spring Boot. Typically, we talk about that executable jar, but in the age of containerization, you have a lot of options there as well, especially with version 2.3.x of Spring Boot. That's another whole talk, which I have given and would happily give again, will happily give again, but not today. So if you're interested in knowing more about that, please do ping me afterward. And of course, you can go with Java 8, which is the baseline for Spring Boot 2 and Spring Framework 5. Java 11 is the latest long-term supported release. That's why it's in there. And then, of course, the current version is Java 14. And that's what I'm going to use today because I want to use the newer Java, I think it's Java 12, Java 13, Java 12 switch statements, I believe. So we'll keep it with that. I also want to bring in my dependencies, and I want to choose a few dependencies here. So I want to get my reactive web dependency. Again, I'm not going to start off with a reactive approach, but this allows me to do either, right? It uses Netty for my default engine. Tomcat would be for if I just did web. That wouldn't give me the option to go reactive later on, so I'm going to just start off here. And then I'm going to add Lombok because I'm a lazy developer. Lazy good, not lazy bad. I don't. Some folks use Lombok in production, some don't. I have opinions too, but I love it for demos because it does simplify my life and lets me focus on the core concepts versus writing a lot of getters and setters and things like that. So I have Lombok. Let's see, I want to bring an actuator because I hope I remember and get the time to show you some neat features of actuator and how that ties in with Spring Cloud Stream and your messaging platforms as well. And then I want to bring in CloudStream. And as you see here, it says it's a framework for building highly scalable, event-driven microservices connected with shared messaging systems. But it also tells you it requires a binder, and that's part of that higher level of abstraction, right? So Stream will tell you, hey, look, if you want to deal with Kafka, you need to add that Kafka binder. If you want to deal with Rabbit, Solace PubSub Plus, Event Hubs, Azure, Kinesis, you need to add the binder underneath because it has to be able to talk to whatever you're wanting to talk to. So it gives you the hint, so you don't just bring one thing in and not have everything you need. I'm going to add in Rabbit, and because why not? We want Kafka too, so I'll add that in. So that should get us started. Now, one nice thing about the initializer of late, the last few months, well, a couple nice things. You can go light mode, dark mode, which is very nice if you keep everything dark mode as I do, and then it's not so jarring. And then you can also explore your project that you're getting ready to download before you download it. So that's kind of nice, right? But I'm going to generate the project. I'll drop this out on my desktop. And in the interest of time, I'm going to go ahead and change my source service to a processor service or POC service. And we'll do the same thing. We'll drop that out there. And then sync service, same thing. And that should speed us along a little bit so we can focus less on the creation and more on code. All right. So we've got our source service. I'm going to open that. Oh, I did want to mention this too. Those of you who've known me for a long time know that my first love, after my wife, of course, is coffee. Coffee, I think I might have died 5 years ago, and coffee has just kept me alive and vertical ever since. But my next love after that is aviation, right? And I spend a lot of time on airplanes. So actually have a pilot's license. So I that's always been a fascination of mine. And I thought, I need to branch out a little bit. And this is a domain that lets me show something a little differently than what I was showing in previous examples and still doing some of my coffee talks. Because this lets me use a service called planefinder.net. And planefinder.net, let me switch over here. So planefinder.net, Planefinder is a company that keeps track of aviation, planes that are in the air. And you can, they have a number of nodes. I actually have one here in my home office that will look for airplanes in the area, and it will register them and upload them so that they can keep a track globally of what all's going on in the sky, which is pretty nice, right? You can see there's not a lot of activity here. There's another competing service, which is PyAware or Sky or FlightAware, I guess, and the PyAware runs on a Raspberry Pi. I also have one of those. But this gives you an idea of the planes flying around St. Louis, at least that are within range of my little node and my little antenna. And these, when you query this endpoint, let me hop out here, you get something like this. So if I query, I just have a little service here that I've created, which is a kind of an API gateway, and it queries that periodically, or allows you to query that periodically, and turn in a list or get a list of airplanes that are in the sky. So it shows you their call sign, their registration number, their IN number in the United States. Every country has their own set of registration numbers or standards, but it tracks this. It shows the route. So this is from St. Louis to O'Hare in Chicago. It shows the type of aircraft, the squawk code on the transponder, things like that. It shows the latitude and longitude, so exactly where the plane is. And this is kind of cool stuff. So if I grab this and plug this into Google Maps or another mapping app, I can see exactly where that plane is. Or of course, I can look at it on the map here. But this shows altitude, the barometric pressure, things like that. So it gives you that idea of what's exactly going on in the airspace around you, which is kind of cool. So let's see. Yeah, Plane Finder, back to that. So I wanted to show this. I created this very simple application that queries my local box here, my local node, and it creates aircraft. And actually, this is more of an aircraft position at the current point in time. It grabs the aircraft information, where it's last seen, where it's located, so on and so forth. And then it exposes these things via a web service, via a REST API. Very simply done. And that's what I'm building off of today. So I use that as my API gateway. We're going to build a set of services kind of extending out from that and connect them via messaging platform. So here's my source service. I'm going to open up my POM, my Maven build file. We can see that here are dependencies that we brought in. We also see that we have both RabbitMQ and Kafka, which that's important here in a moment. If you're dealing with one particular messaging platform, Spring Boot's auto configuration says, look, you have Spring Cloud Stream on your class path, you have, let's say, a Kafka binder on your class path, and it will create all of the beans that are needed to deal with Kafka through Spring Cloud Stream automatically. You have to do nothing more in order to talk to Kafka. Since I have two different binders here, I have a binder for Rabbit and I have a binder for Kafka, we're going to need to provide a little bit of guidance to deconflict those so Spring Boot knows how we want to handle that. It's very easily done, but obviously since we're not giving Spring Boot enough information to fully auto-configure that, we have to give it just a hint. So I'm going to go to my application properties, and we're going to define a few properties here. I'm going to start with my server port. And of course, you see that the default is 8080. I don't want any port conflicts, so I'm just going to have, when boot starts up, if you set server port equal to 0, it finds a random open port and uses that, and that's sufficient for our use here. And then I also want to set up my bindings, which I don't have anything defined yet, so we'll come back to that. But then also I want to set up my Kafka binder information here, so that when we do switch to Kafka, we're starting with Rabbit, that's fine. But when we do switch to Kafka, we want to be able to have Kafka deal with certain things, again, automatically on our behalf. So we want it to be able to automatically add partitions. That's a nice, useful feature, especially in development. And we want it to binder, Spring Cloud Stream, Kafka binder, and minimum partition count of 4. We'll start with that. I also, since we wanted to show some things with Actuator, I want to expose all of Actuator's endpoints. Now, this is something that it's not by default, right? It's secured by default. So it shows a very limited bit of information in terms of an info and a health endpoint. That's it. And that's all you typically want. You don't want to expose all of your environment and all of your class path and all of the beans that you're creating in your application to potentially potentially bad actors. But in this case, what I'm doing is kicking down the door. I'm opening up everything so everyone can see this. So please don't do this at home, not in prod, please. So yeah, this is kind of important, right? So dragons are here. Right. So that's all I'll say about that. This is a bad practice in prod, a good practice in a demo. So, all right, so let's go to our code. Now, in the interest of time, what I want to do is go ahead and pull in my actual domain class here. And I don't like to copy paste code. It's a terribly shameful thing. But in this case, again, I think it's useful because it gets us on the right track faster and avoids my typos in this case. So this is our data class. This is what we'll be pulling in from our API gateway for our aircraft. And we'll be pulling in information about, the ID is kind of just a random, not random, but it's an identifier for that particular position record. And then we have, for that particular aircraft position at that point in time, we have a call sign, a registration number, the flight number, the type of aircraft, we have altitude, heading, and speed, and we have the lat long. So we know latitude and longitude positionally exactly where that aircraft is at that point in time on the globe. I'm also going to, and this is kind of a matter of personal preference, but I like to create a configuration class and put my beans that I'm creating in there. You can certainly do it in a Spring Boot application annotated class because that also is a configuration class. I just like to keep things separated here. I think it's kind of nice. So it keeps things a little more modular and cleaner. So this will be my aircraft feeder class. So for my aircraft feeder, what I want to do is to create, first of all, a web client so I can query my aircraft API that I'm running off of my box here. So, so I'm going to create a web client. Now, the web client is something that came into being in our reactive web module. So it starts off with a reactive non-blocking approach. Going from non-blocking to blocking is very easy. Going the other way around is not easy. So we start from our reactive point, but as you can see very quickly, we immediately go back to our imperative approach, and then at some point we will convert that to the fully reactive approach. So I'm going to use my web client create, and we'll provide our URL, and that is at http://localhost 8080. And then what I want to do is create a bean here. And we're going to create a bean, which is a supplier, again, using the functional API. Now, the interesting thing, and this is the one thing that I wasn't able to show with my coffees, because I would just kind of generate the coffees as, one per shot, not espresso shot, but anyway. But what this does when I pull that aircraft position for a position list is I get a literal list of positions that are shown at that point in time. So in this case, I see one aircraft, but if I wait a few seconds or a few minutes, you may see 2 or 5 or 10 different aircraft that are flying and within range of my node here. There's a second one that pops up. So when I query this, I may get a number of different aircraft positions that come through at a shot. And then when I query it again, I may get that the same aircraft with an updated position and or different aircraft with a position that now register. So I'm actually querying a list of aircraft here, or getting a list of aircraft, supplying that downstream. This is different from the coffee application and many applications that we use, because you don't get or produce a value at a time. You get this kind of cluster of values. And this allows me to show some very neat capabilities of Spring-Clad Stream as well. So that's kind of cool. So I'm going to send aircraft positions. And a supplier is what? It's a functional interface with a single abstract method. And as such, we can provide a Lambda for that. So let's do this. Now I'm going to I think what I want to do is actually show that we're going to create a list of aircraft, right? And we'll call this our AC list equals, and we'll do our client get, and we'll retrieve the results that come back. And then I want to convert the body, whatever we get back, to a flux of aircraft. And this a flux. And I didn't really mention this, go into this much. Josh, I think, will cover this quite nicely as down here in an hour or two. But just to give a little bit of a background, the idea of a flux or a mono, these are both reactive streams publishers. And the Reactive Streams API consists of 4 interfaces. The Reactive Streams API has a publisher, which produces 1 or more values, a subscriber, which consumes those values, a subscription, which is a contract entered into between subscriber and publisher, and a processor, which incorporates a subscriber and a publisher, because then it subscribes to values, transforms them, and passes them on. Sounds very complementary to Spring-Clad Stream, right? With the suppliers, the functions, and the consumers. And as you see, it actually works very nicely together. But we're still in that React sphere, right? So what I need to do is do a collect list, right? And let's see. So that should be sufficient, actually. Yeah, that's not exactly what I want to do, though. So yeah, well, let's go on here. So if I do a .log, no, actually, I can't do the .log yet. So I'm getting ahead of myself. So now we have our list. I do want to take our list and do a for each, and we'll just print this out and see what we have, so we can kind of see what we're doing, and then return AC list. And yeah, so I'm going to back up here. Actually, I want to do a to stream first. Yeah, and then I'll do a collect. Yeah, I'll do that. That works. Okay, so that's not terrible, right? So that should get us up and running. I think I've got everything I wanted to do there. So that's my source, right? So this should query our API gateway for our aircraft positions. It should collect, grab that collection as the query comes back, and then pass that on. So now I need to take this, my send aircraft positions, and go back over here and finish up with our bindings. In Spring-Clad Stream, we actually bind to the name of our bean that we're creating here. So our supplier bean, we have the ability to define input channels. In this case, we have 1 input channel. It's pretty simple, but we have the ability to deal with a number of input channels and a number of output channels. And actually, this should be out because this is our source, right? This is our supplier. So it has an output channel. By default, that's it. It produces values and it sends them out. And then I want to set up my destination. We'll call this processor because this is just the destination we'll be pointing to. And then I can actually set up my binder here. And we'll say that that is going to go to Rabbit. You also, in lieu of that, can set up your Spring Cloud Stream default binder and just say it goes to Rabbit if you don't designate. So even if you have 1, 2, or 5 different binders on your class path, you can set this up and it will default to that. But we're going to just define it here, so that's fine. Great. Now I don't want to go ahead and start querying and pushing these values into the pipeline because I don't have anything on the other end to catch them just yet. So let's go ahead and create our processor and our sink. We'll unzip our processor project. We'll open that up. And let's see, so that looks pretty good. Now I do want to also, we'll go here and go to our application properties, server.port equals 0, Spring Cloud Stream bindings. In this case, we'll come back to that again, Spring Cloud Kafka, Stream Kafka binder, minimum partition count 4, Spring Cloud Stream Kafka, auto partitions true. And again, our management endpoints web exposure is star for our actuator. Again, please do not do this in prod. There we go. Okay, just to make sure we cover that. All right, so our application class, our code. Once again, I want to grab my code here. So this is our aircraft. I'm also going to transform this to our aircraft here because this is our transformer, right? This processor is our service that we're going to be transforming aircraft to essential aircraft. And these are the things that we're going to be passing downstream to our consumers. So once again, I want to ignore anything that that doesn't make sense coming in. And then we're going to be dealing with just the essentials. And I'm going to strip out everything except the call sign, the registration, and the type. And then the manufacturer. I want to be able to show who manufactures that plane that's out there flying. And that's based on the type. And since I can't memorize all these, I wound up just troubleshooting and going through until I could isolate enough of these to make it a useful example. And that's the new switch statement here. So if it's it starts with A2 or A3, like an A330, A350, it's an Airbus. If it's a B737, 747, 777, it's a Boeing. You have Embraers, you have Learjets, you have occasional McDonnell Douglas still out there flying, Pipers, Cessnas, Beechcraft in terms of the smaller aircraft. And then if it's other, I just kick out the, just so I can see what's going on. And then I set the manufacturer so we can deal with that. So now what I want to do is create my configuration class, configuration, there we go, class, and this will be our aircraft transformer class. Yeah, so that should do nicely. And then what I want to do here is create my bean, and this is a function. And we're receiving, again, that list of aircraft, right? And we're going to be transforming that into a list of essential aircraft. And we'll call this transform AC. So again, a function is what? It is a functional interface with a single abstract method. So that's the Lambda once again. So we take our list, our aircraft AC list. Yeah, we'll just do that. Okay, so I want to here create a list of essential aircraft. We'll call this EAC list, and we'll set up this as a new array list. So we'll initialize this just empty, right? And we take our AC list and we will do a for each. And for each of those, we take our aircraft and we do a new essential aircraft, right? And we take our AC's call sign, our AC's registration, and our AC's, our aircraft's type. So that should do that. Yep. And then we want to take our EAC list our new EAC list, and we'll do a for each, and we'll do a system.out print line so we can see what's happening. Seeing what's happening, I find, is very good. And we'll return our list of essential aircraft. Should work, right? And we'll take this function and we'll plug that in for our bindings. In this case, we have an input channel. In this case, also just a single input channel, and that's fine. And we'll set up our destination. We had said that this would be from processor. If we go back to here, our destination out for source is processor. So that's exactly what our destination in is for our processor, for our function here. We're setting up our group. This is a consumer group. We'll just call this processor as well. And then we want to set our binder here as Rabbit. But we also have an output channel, one or more output channels in this case, because we have a function that's taking in a value and producing a value and needs to send that out. So out, how am I doing on time here? I keep double checking that. And 16 minutes, this is great. Tons of time. Okay, so we take this output channel, a single one in this case, and we set the destination equal to sync. Now we don't need a group because this represents a consumer group. So in this case, on the input channels, you're consuming. On the output channels, you're producing. And we're producing essential aircraft and sending them out. So we don't need that. But we probably should indicate that our binder here, again, is Rabbit. And you could, again, take this up here to a default. But I'm not going to do that because I want to show some features later. So we have this. Should be done. Should work. Let's go ahead and run this. And that should work just fine, even though we don't have anything coming in yet. But I just want to make sure that it does fire up and I don't have any typos in there. Everything looks happy. Yes, up and running just fine. And yes, we're committed to or connected to Rabbit. We see here AMQP, Rabbit Connection Factory. So all good. And finally, we just need to create our sync. Come on, there we go. Sync service, there we go. Had me a little worried there. I didn't spot it immediately. All right. So one more time, we got our application properties, server.port 0, Spring Cloud Stream bindings. Come back to that. Spring Cloud Stream Kafka binder auto add partitions true. Spring Cloud Stream Kafka binder minimum partition count 4. Our management endpoints for our actuator again. One more time, please. Not in prod. Screaming cat. Okay, so we're good there. So let's go to our application code here, and let's create our at data and at all constructor, and this will be our class essential aircraft, right? Craft type private final string, and this will be our call sign reg and type and manufacturer, if I remember correctly. If not, we'll come back and fix. Call sign reg type manufacturer. It is a good day. All right. Okay, so we're good there. I'm going to create my configuration class here, and this will be our aircraft position consumer class. And we'll create our bean. This is a consumer of a list of essential aircraft, right? Come on, there we go. And let's see, we'll just log positions. Again, a consumer is what? It's a functional interface, single abstract method. So we'll do a return, and we're getting a essential AC list, and we'll do an EAC list dot for each, and we'll just do a system.out print line, and we'll just log it. Okay, so log positions. Once again, we go back here to our bindings. We have an input channel because this is the consumer. It just consumes. And we say our destination in this case was sync. It needs a consumer group. We'll also say that's sync. And we'll have our binder, which in this case is, again, Rabbit. So let's run this. and we're almost ready for showtime. And then we can do some really fun stuff with converting this to reactive and showing actuator and maybe flipping between Kafka and Rabbit and things like that. Let me see the time. 12 minutes. This is great. Okay.
I think
Our
we
sync
have
is up and
something
running.
from our chat. Did you add the
Oh,
essential
yes.
aircraft? Yes. So EI list and essential aircraft, is it mapped correctly? You see?
Oh, in the processor?
Yes.
Let's find out. So let's see. List aircraft to list essential aircraft. Looks good. Proof's in the pudding. Let's find out. I'm gonna start sending some positions and we'll see what we get. If not, we'll fix it. This is the wonderful thing about having a great group of developers, because if you miss something, somebody's got eyes on it and will spot it, hopefully. So we've got some aircraft flowing.
People watching
Oh,
carefully on what you're doing.
yes, that's good. And oh, let's see. So I've got an error here, so that's fine. Let's go back here. Oh, I didn't filter. Yes, I do need to filter here because there was something that I'm trying to think. Was it the reg number that would come through as blank sometimes? I think it was. Yeah, yeah. So let's see. If I filter this out, and this is in my source, that's good. So we'll take our filter, and if it's an aircraft that let's see, the call sign registration. I think it was a registration. Is empty. So if it's not empty, we should pass it on. So let's go ahead and let me see where just to double check the errors that I was getting here. Because I found that occasionally I get junk data, go figure, right? Not much I can do about that other than just filter it out. And we're just getting that. Oh, it's the type that's coming through that's not, let's see, why is that logging? I'll kill that. That's kind of annoying. So let's see. So here, error. Yes, I think so. Let's see, out of bounds exception. So yeah, something is coming through with junk. Let's see. That one has a registration. Yeah, we'll restart it and see if that cleans it up. If not, we'll troubleshoot further. So while that's doing that, I'll go ahead and restart this. Oh, I didn't kill the type, the errant type of it showing. Let me do that.
Sometimes
That's
there
all
are
right.
no
It'll
flight.
show. Yeah, so I have to restart it to kill that, but that's fine. So that's coming through. So are we getting anything with our sync? And we're not. Call sign is null. That's fine. Again, this is brand new. This is the first time I've given this
Okay.
particular
So
talk.
chat members said that essential aircraft, which is mapped in a EI list, is not added. Maybe we should check that.
Oh, let's see. Hold on. That's a good catch. Let's see. So so I've got I'm taking my list of aircraft and I'm producing. Oh, great catch. Oh my goodness. Yes. Okay. So let me stop the flow of aircraft here. No wonder it's not coming through. So let's see. So for each. So yeah, that
You do not get it to list. EIC list is just empty, I guess.
yeah, that's let's see. So I need to for each. Huh. Oh, yeah, okay. So let's fix this here. So
You have to add it.
good. Yeah. So oops, EAC list add EAC. That should make that considerably happier, right? Let's find out. Wow, good catch. I was just blindly going through and it just seemed so happy and nothing was happening.
Yeah, we have some
Okay.
delay. It's line 31 exactly, so
Oops.
people are watching carefully.
Yeah, that's good. That's good. So let's see. So there's my sending. That's my source processor. Oh, that looks much happier. Look at that. So now here's our sync. So we're getting aircraft. Excellent. Good catch, by the way. Thank you very much. Sometimes you're too close to the code and it all looked great and you're missing that one key bit. Okay, so we have things passing through and that works reasonably well. Let's see. So what do I want to show next? I think what I really want to show next is, let me stop my source. Let's go to reactive because I'm afraid we're going to run out of time. And that's kind of the big deal because this works as it is, right? I mean, you've got your supplier of list of aircraft, but it is a little clunky. So if I change this from a list to a flux, then we get our full reactive publisher capability. So I'm going to just clean this up just a little bit. So I'm going to take this and do a client get. I can get rid of my toStream and collect to the list. I can get rid of this. And let's see, so that looks pretty good. Now, how do I see what's going on? Well, I can just do a log. That's pretty nice, right? Actually, I kind of like that indented better, but that's fine. So that will now take us to a reactive streams publisher, a flux. A flux is 0 to n values. And I'm going to leave it like this, even though there's a little bit of an issue, because I want to show what that issue is as we go and how this is very nicely done by Spring Cloud Stream as well. But we're going to now produce a reactive stream, a flux. Each time there'll be a non-blocking stream, if you will, of aircraft or aircraft positions that I'm passing down the line. I'm doing this, I actually need to go and modify my processor and my sync to handle this as well, because they're no longer going to be getting a list. They're going to be getting a flux of aircraft and creating and producing a flux of essential aircraft. So the same thing here. I'm going to take this and let's see if I can. I'm going to have to speed things along, I think. So I'll look at how best to do that. What I want to do is, let's take this flux. So this will be, instead of an AC list, this will be a flux of aircraft flux. That'll work. And I'm just going to do a aircraft flux, and we'll map each of those. And once again, I can just do this dot log, right? Let's see, so map, oh, one more. Right, yep. Log, nope, I'm off on my spacing here. Map, oh, here we go. That will clean that up. There we go. That makes that a lot nicer. All right, so I can get rid of this and this and that. Ha, much better. Okay, so that cleans that up nicely. If I go ahead and restart this, and then we'll go and do the same thing for our sync, which is even simpler yet, as I can take this consumer of list and make this consumer of flux. And we'll just take this flux and we'll do a flux subscribe and restart. We'll go back and we'll double check our processor's restarting. What happened there? Sync is restarting. And our source, we will restart. Okay, now interestingly, you saw or will see one set of values. And why is that? Because here's the interesting part, and that's why I said I wanted to leave this the way it was. We have a bean here. And when you deal with reactive publishers, the idea is that when you have a supplier, you'll get a value and then you'll get another value. And you may get those values very rapidly or you may get them sporadically, but it's expecting a value and a stream, I should say, a stream of values. The difference is, in this particular case, we're getting a stream of values as a value, right? So we're getting this grouping, this list, or this flux of aircraft, and then it stops. It doesn't poll again. So that seems like that could be a problem, except for the fact that there is a pollable bean construct, a pollable bean annotation that just says, hey, look, you're going to be getting groupings of values. This is the one thing I said I couldn't really demonstrate very cleanly in my coffee demos, in that in this case, this is a perfect example, because you're getting these clusters of values that you need to periodically just check to see, I need a position report. Give me the latest set of positions, the latest group or collection of positions for a particular set of aircrafts that are in your. So what I'm doing is setting this up to be a pollable bean, and then downstream we can see that we're now getting that feed of data as we would expect. So the functional reactive approach is actually much cleaner than the functional, semi-functional imperative approach, and it gives you arguably much better results. So I do want to say, because at this point you're probably wondering, how does it know how often to poll? How does it know, how's it reading my mind? Right now it looks like it's about 1 per second, and that's exactly what it's doing, is a 1 per second default on the poll. So if we set our Spring Cloud, let's see, what is it? Spring Cloud Stream Poller, a fixed delay of, and in this case it's 1000, right? That's the default. In fact, let me just show that. It doesn't show up because it's too big a print. But I'm going to set this to every 5 seconds, and then we'll restart this. And again, this goes back to there are sensible defaults. There are opinions that Spring takes, but you can override these very easily via typically either creating a bean, or in many cases just setting a property.
Thank you,
Yes.
Mark. Thank you, Dima. I think
We are a bit running out of time.
Yeah, we're running out of time, so we can continue in discussion zone.
Okay.
We got working state here, which is really cool.
Yes, everything works. I didn't get nearly as far as I wanted, but happy to talk more in the after chat.
So yeah, planes in the air, join us in discussion zone.
There are some questions there, so we were able to answer the questions. They're still pending in the chat in the Zoom, which is published, and then we can continue actually a little bit to finish this thing. Well, for the live streaming, thank you very much. So waiting all the people in the Zoom room.
Yeah.
Yes, hope to see you there, and hopefully next time we'll get a 2-hour session.
Oh yes,
that sounds nice.
Thank you so much.
I will join you. I guess I drop off of this one and then join in the other one?
Yeah.
Yes.
Exactly. Okay, I will meet you there.
You just join Zoom, Mark. Yeah.
Okay, I will meet you there momentarily. Thank you.